Okay, this is Professor Corbet. We're going to do linear systems in two variables using the substitution method. Okay, so we're going to start with 4x plus y equals to 24 and 2x minus 3y equals negative 2. We're going to go ahead and name these equations so we don't get lost. We'll call this equation number 1 and this one equation number 2 in red. Okay. Now by the substitution method, we're actually looking for a value to make our lives easier, which is singular or just y or just x. And we can see right away here the y in equation 1 is all on its lonesome, so it'll be easier to pick on that value. So we're going to go ahead and rewrite equation 1. We're going to take the 4x plus y equals 24, and we're going to subtract 4x from both sides, and we'll get y is equal to 24 minus 4x. This is our new equation number 1. By doing that with equation number 1, we see that we've got something a little easier. And we're going to take that number 1 and we're going to put that in equation number 2. Equation number 2, remember, was 2x minus 3y equals negative 2. So in the y part, I'm going to substitute what y is here that I wrote out, and that is 24 minus 4x. Now I can multiply that out. We'll have 2x minus 3 times 24. That'll be 72. And then minus 3 times negative 4, which will be plus 12x equals to minus 2. I can simplify that a little bit. I've got the x's here that are repeated, so I've got 14x minus 72 equals to minus 2. And then I can go ahead and add 72 to both sides, and I'll have 14x is equal to 70. And then I'll divide both sides by the 14, and that will leave me finally with x is equal to 5. Now that I've simplified it to that point, I can go ahead and resubstitute that back into my system. So I have x is equal to 5, so I'll put that back perhaps in equation number 1. So I'll have x equals to 5 in equation 1. So that'll be 4x, 4 times 5, plus y equals 24. And I see that's 20 plus y equals to 24, and then I could subtract 20 from both sides, and I get y equals to 4. That's very nice. That leaves me with a solution of x comma y is equal to 5 for x and 4 for y. Well, if I look back at my equation, my system, I've used the first equation to do that, so I'm going to turn around and check my answer. So I'm going to check 5 comma 4 in 2, so I'll have 2x, 2 times 5 minus 3 times 4, is that equal to minus 2? And I'll get 10 minus 12 equals minus 2 equals minus 2. So I see that yes, finally x comma 5 is equal to 5, 4, and I've checked it in the solution.